We're going to have a look at how to draw a standard hexagonal bolt and the nut that would fit onto that bolt. And if we have a look carefully here, you can see that this bolt has got a head. This part over here is what we know as the head. It's a hexagonal head. This over here is what we call the shaft of our bolt. And then this over here that you can see quite clearly there, that is what we call the thread of our bolt. And that of course holds our bolt and our nut together. And then you can see our nut over here. Our nut is also hexagonal, and if we turn that slightly, you'll be able to see that there's a little bit of thread on the inside of that nut. Okay, you can see it there. There's a bit of thread on the inside of the nut, and of course that thread on the inside of that nut fits into or onto that bolt. Now we use the metric system, and because we use the metric system, when we talk about bolts, we're going to talk about the M value of a bolt. The M value of a bolt tells us what the diameter is of our shaft, this piece here, that diameter. And of course diameter means the distance from the one end on this side here to the other end on this side over here. So if we had to talk about an M16 bolt, okay, an M16 bolt, we would then be talking about the distance from this end over here to that end there being 16 millimeters long. That would be an M16 bolt. Now there are a bunch of standard measurements that we have to use when drawing bolts and nuts, and that's what we're now going to go over. When we go and start the drawing of this, we're going to start with the top view, okay, of our bolt. And if you have a look there, you see of course that the top view of the bolt is hexagonal, and you'll see clearly there's an M there. That of course makes us know that this is a metric bolt. And then you'll see there that there's a circle on the inside of our bolt which touches the very edge of the sides of the hexagon. And then if we look carefully, you'll also be able to see that the ends of the head of the bolt are slightly angled down. Okay, it's important to note that because we're going to draw that in later. And then if I put my bolt back down like this, you'll be able to see now that the position of my bolt head here is what we call the three faces position. In this case we can see three different sides of the bolt head. There's one face there, okay, there's another face over there and another face there. And then if we turn our bolt to the side, we can then see, if we put it into that view, that would be a two faces position, because you can only see two sides of the bolt head in that view. Okay, so we're now going to go and start using our M16 value. Okay, remember that the M stands for metric, and then the number tells us the diameter of the shaft. And we're going to go and start with the top view of our bolt head, and we're going to use a few very specific calculations to be able to then go and get that top view and draw the rest of our bolt, and then have a look at our nut. So that is what the top view of our bolt is going to look like. And to start us off, we need to be able to work out what the distance is between the two flat edges of our hexagon. Now that distance is worked out by going and taking the M value of our bolt and multiplying it by 1.5. Now that's a standard calculation that you're always going to do. They'll give you the M value of the bolt. We said we're going to use an M16 for this example. And because we're using an M16 to go and get the distance now between the two flat ends of my hexagon, I'm going to use this little calculation that you see there, and I'm going to say 16 multiplied by 1,5, which gets me a total of 24 millimeters. That 24 millimeters is now the distance between that edge of my hexagon and that edge there. That distance is also known as across the flats. Okay, and you'll see it in questions that they indicate it as A/F. That means the across the flats distance. which is the distance from the one flat end to the other flat end of that hexagon. Now that I know what that distance is there, my first step is now to go and take that distance and place my compass on half of 24 and go and draw a circle, which will then be a diameter of 24 millimeters. So I'm going to put my compass now on 12, which is half of my 24. Okay, and when I draw my circle, that of course is then going to give me the inside circle of my top view, and I'm going to draw that as a dark circle because it's going to stay in my top view. And then I'm going to take that circle now, and I'm going to take my 60-degree set square, and I'll use my 60-degree set square to go and construct a hexagon around that circle. And to do that, we just need to make sure that we go and draw tangents to the circle, which are lines which just touch the very edge of the circle. So I'm going to draw construction lines now, just touching the very edge of the circle, one at a 60-degree angle, one right at the bottom over there, and then another one at a 60-degree angle here. Turn my set square around and I'll do another one at a 60-degree angle there, each of those just touching the very edge of my circle. And then of course the one at the top I'm going to do dark. And then I can finish off my hexagon by just going and drawing in each of those sides dark. And that will then give me my hexagon with a distance of 24 millimeters across the flats, which is then completes the top view of my bolt. Okay, so just as a reminder now, we went and got that distance, okay, from there to there by drawing a circle which has a diameter of, we said, 1.5 multiplied by our m value. So we took our m value, 16, multiplied by 1.5 gave us 24. We put our compass onto half of 24, and that's what then gave us our circle, and we then used that circle to go and draw a hexagon around it to go and get the top view of my bolt. Now we're going to use that top view to go and construct our front view over here, and the first step we're going to follow is we're going to take each of the corners of the hexagon and we're going to project those down as construction lines. We're also going to project down the center of the circle. Okay, then we're going to include a line to indicate the top of the head of the bolt. Now, how are we going to figure out how high the head of the bolt is supposed to be? Well, we have another calculation for that. Okay, so if we go to what the front view is going to look like for your bolt, there's our front view. The height of the head of a bolt, its calculation that you will always use is going to be the m value multiplied by 0.7. That will give you that distance over there. So because we've got an M16, we are going to go 16 multiplied by 0.7, and that will give you an answer, if you put it into a calculator, of 11.2. Okay, we can't do 0.2 of a millimeter, so we're just going to use the 11 millimeters, and that will then be the height of our bolt head. Okay, that height there. So now that we know that height, we can go back to our drawing and we can go and measure our 11 millimeters here from the line that we drew in for the top of the head. Mark that off. Okay, I'm going to draw it in as a dark line, because we know that in our front view that is just going to be a straight dark line for the bottom of the head of our bolt. Now we need to be able to go and get the top end of that bolt, and the top end of that bolt, it looks a little strange. Okay, if you have a look at our bolt here, the top end of that bolt is slightly rounded on the ends, so when you draw it, it's going to look like that. Okay, showing those little rounded parts over there, and then you'll see that the two ends over there are both cut off slightly as well, and then you've got a dark line at the top. Now there's a method to be able to get each of those little curves over there. Okay, so we're going to have a look at that. To get those little curves, we're going to take our 60-degree set square. Okay, and now you can see clearly here that you've got a little rectangle that's been formed over here by the lines that we brought down from the corners of our hexagon in our top view. We've got another little rectangle over here, and then we've got a bigger rectangle over there. The one arc is going to fit in here, our other arc is going to fit there, and then our big arc will go in this rectangle here. To start us off, we're going to take our 60-degree set square, and from the top left corner of that first rectangle, I'm going to draw a construction line going down, and then I'm going to flip my 60-degree set square around, and I'm going to draw another construction line from the top right hand corner of my other rectangle, okay, to give me something that looks a little bit like a V. And then I'm going to take my compass, and I'm going to place the pointy end of my compass on the point where those two lines have come together, and then open it up to the very top end, to the top line of the head of my bolt, and I'm going to draw an arc which fits into the middle rectangle. Okay, so that arc must start over there, and it must stop there, and it must touch the very top of the line there that indicates the top end of the head of my bolt. Okay, that's the first arc. And then to get the two smaller arcs, I'm going to take my set square, my 60-degree set square, I'm going to turn it around again, and then from that top corner over there on this smaller rectangle, from that top corner I'm going to draw down another 60-degree line, and I'm going to do the same thing on the other side. From that top corner, draw another 60-degree line, so that I've got two smaller V's on the left and the right in those little rectangles. And those points now that have been created by those V's, I'm going to put my compass point onto that point, and again I'm going to open it up so that it touches the top line of my bolt, and I'm going to draw an arc which fits into that little rectangle, and then I'm going to do the same thing on this side over here. It should be the same size arc, and I'm going to draw an arc again which touches both ends. Of course, be careful to make sure that you don't have happen what I've just had happen there, where my compass has slipped. Going to make sure that you hold tight onto your compass. Okay, so once you've got those two arcs, then just redraw that in there. Okay, that gives you your top two arcs. Okay, and then of course your big arc at the top over there from each of, by using each of those V's. Okay, now that you've got those little arcs, What you're then going to do is you're then going to join the top of this small arc on the left with the top of the small arc on the right over there with a dark line. And then you're going to take your 30-degree set square and you're going to draw a small little tangent line onto the end of that small left-hand arc. Okay, you can see it's a very small little line over there. And then we're going to do the same thing on the right-hand side. Now those two little 30-degree lines there are important. Okay, because those two little 30-degree lines show us where the edge of the top of our bolt is. And if we then just make sure that top line then joins to those two little 30-degree lines there, that then finishes off the top part of our bolt. And then what we're going to do is we're going to draw in the dark lines going down. So we'll draw a line from the bottom of our bolt to where it hits into that 30-degree line, no higher than that. It mustn't go to the top end of the bolt over there. And then we do the same thing on this side, and then the ones in the middle, this one here, only goes up to where the two curves come together. You can see that point there where those two curves have come together. Okay, that line must stop where the two curves have come together. Mustn't go any further. And the same with this one here. Okay, so you'll see that there's a little gap that's now been left over there, another little gap left over there. So that line must not go into that little gap over there at all. That then completes the top end of your bolt. Just as a reminder, we started with that first V taken from the top right and left hand corners, put our compass point there to draw that first big arc, and then we did another little line coming down from the other two corners of these two rectangles, put our compass there to draw that small arc, compass there to draw that small arc. Then we went and drew a line across the top joining the two small arcs. We did two 30-degree little lines down here, okay, with our 30-degree set square facing that way for this one on the left, and our 30-degree facing that way for the one on the right. And remember, they must just touch the edge of the top of those two arcs. And then we went and drew in our lines coming down to finish off the top of the head of our bolt. Okay, now we've got the head of our bolt. Now we're going to have a look at drawing in the shaft. And now remember, for the shaft, okay, is our M value. So if we go back to our drawing here, that shaft over there is the M value. So our M value for this, we said, was 16 millimeters. So the distance from the one end to the other end of our shaft there must be 16 millimeters. And if you look at this drawing here, you'll see that the two lines over here for the head of our bolt do not meet up or line up with the lines for our shaft. So when you're drawing your bolt, you can't just go and draw in a shaft now in line with those two lines over there. That would be wrong. Because it's an M16, we know that the shaft has got to be 16 millimeters wide. We're then going to go and measure from that center line over there. We're going to measure 8 millimeters to the right and 8 millimeters to the left, okay, to give us our 16. So my 8 millimeters to the right is there, and my 8 millimeters to the left is over there. Okay, those are the 2 points now that we can use for our shaft. And I'm going to draw my shaft down on both sides, and I'm going to draw that down any length. Okay, and the reason why I'm drawing it down any length is because the length of your shaft is determined by the question that you get given. Okay, that length there is determined by the question. There's no special formula for it or anything like that. That length will simply be determined by whatever this bolt holds together. Okay, it's got to fit through the part that it's meant to hold together, so that length they will have to give to you. Okay, so now we've got the two lines there now which are for our shaft. Okay, we've drawn those in, and now The next part we're going to have to go and draw in is our thread. Okay, remember that the distance from that side to that side there was the M value, in this case 16 millimeters. Okay, so we've gone and we've drawn in our shaft there. Now the part that you can see on the inside over here and on the end there is our thread. Now we don't draw the thread as you see it on this bolt. We don't draw in all those little arcs, okay, to indicate the thread. We use a standard which looks like this, drawn on the inside of the shaft to indicate that there is thread there. And again, the length of the thread, so from that line here to there, they'll have to give you in the question. Okay, there's no standard measurement to go and work that out, but there is a standard to go and work out what the distance is from the edge of the shaft to the line indicating the thread over there. That little distance there, okay, that is worked out by going your M value multiplied by 0,1. That'll give you that little distance there, and then of course the same distance on the bottom of your shaft, also your M value multiplied by 0,1. And because this is an M16, that'll be 16 times by 0,1, which is 1.6 millimeters. Okay, I can write it in over here. It would be 16 multiplied by 0,1, which is 1.6 millimeters. Okay, 1.5 millimeters. So I'm now going to go onto my drawing and I'm going to measure inwards 1.5 millimeters. Okay, on my one side, and 1.5 millimeters in on the other side. Okay, and I'm now going to draw in just a construction line, which is 1.5 millimeters away from each of those sides. Okay, that I know is my thread line now, coming down. And then at the bottom over here, you can see I've left that blank, because at the bottom, if you look at this drawing, the bottom over there, that over there is a 45-degree angle that comes down. Okay, a 45-degree angle there and there to end off my bolt. And the size of my thread here, again, as I said, they will give that to you. So for this drawing, I'm just going to put in a line which ends my thread. They would tell you where it ends. I'm just going to draw one in to end it. And then at the bottom over here, this is an important construction. Okay, at the bottom there, you can see that I've drawn in my two lines now, which indicate the inside part of my thread. Okay, that was 1.5 millimeters away from each of the sides. I'm now going to take my 45-degree set square, and I'm going to draw a line from the end of my bolt at a 45-degree angle to then touch my line, which was drawn 1.5 millimeters in from that edge. And then I'm going to flip my 45-degree around, and I'm going to do the same thing again to that same line that I drew down. And then I can draw a horizontal line joining those 2 points, and then I will have to have a line in over here which joins those 2 corners as well, which would look like that, which shows the end now of my bolt, end of the shaft. And then there'll be a dark line that has to come up, as we said, to indicate the thread. So we'll have a dark line which goes in there, and then another dark line in there which indicates my thread. Okay, and remember we worked out those distances by going 1.5 times our M value. And then right at the top over here, to show that the thread ends, that it tapers off, we use our 60-degree set square. Okay, 60-degree set square, and we go from where our thread ended, we're going to draw a 60-degree line up till it hits the edge of the shaft, and then flip our 60-degree around, and we're going to draw another line up at a 60-degree angle till it hits the end of our shaft, to then go and complete our bolt. So if we just look over here on this one, which is a bit clearer, Okay, those angles over there, as said, are 45-degree angles, and these lines up top here, those are 60-degree angles. And in the question that you do, they will have to tell you what the length of the bolt is, and they'll also have to tell you what the length of the thread is. And the length of the thread will be given from the end of the bolt up until that line there. These little 60-degree lines you'll have to add in afterwards. That then completes the construction of the top view of your bolt as well as the front view of your bolt. And in part 2 of this video we'll have a look at drawing on the nut onto a bolt.